So let's begin and let's work through some examples from 8.2. So 8.2 is on law of cosines. So just as a reminder, law of cosines is c squared equals a squared plus b squared minus 2ab cosine of angle C. Now there's nothing significant about the letters A, B, and C. Just note that um, if we have C on the left side, that's the angle that we're taking cosine of. So if C is over here, then these angles are A and B. Those are the letters that are in front of here. So if we have sides A, sides B here, we have side A, side B here. Also, if we look at drawing a triangle ABC, angle A, angle B, angle C, so this will be a little A, C, and B. Angle C is the angle between sides A and B. So this angle is between those two sides. So whatever letters we use to call them, this angle is between these two sides. This side is across from that angle. So let's work through one. Let's erase that. So let's draw a triangle where we have ABC. Angle A is 26 degrees. Side B is 13. Side C is 28. And there's side A. So as normal, we want to begin by listing our angles and listing our sides. We know angle A. That's the only angle we currently know. We know side B. And we know side A. So we can't use law of sines for this because we don't have an angle side pair. If we have an angle side pair or can come up with an angle side pair, we use law of sines. Otherwise, we use law of cosines. And when we use law of cosines, we only have to use it once, and then we can finish the problem with law of sines. So if we want to find A, then we'd put A squared on that side, and we would put cosine of angle A on the other side. So the sides that make up angle A are 13 and 28, so those are the ones that go on the side with the cosine. So angle A here, side A here. Sides B and C here, sides B and C here. So now we just need to use our calculator and get these numbers. One place we have to be careful is here with our signs, because we have a minus or a negative in front, and sometimes when we take cosine, we also have a negative. So when I type this in my calculator, I'm going to type in -2 times 13 times 28 times cosine 26 degrees, and whatever sign my calculator tells me, that's the sign I'm going to write down. So we have A squared equals 13 squared, which is 169, plus 28, not 8, but 28 squared, which is 784. And then if we do -2 times 13 times 28 times cosine of 26 degrees, we get minus 654. So A squared is 169 plus 784 minus 654, 299. So A is the square root of that. So about 17.3. Did I say A? Oh, I wrote this 28 in the wrong place. That is C. So A, 17.3. All right, now notice we have an angle side pair. So once we have an angle side pair, then we can get the remaining pieces. Since I'm not sure if angle C is going to be obtuse or acute, I'm going to find angle B next. So when I do sine of angle B, I'm going to put it over 13, and then sine of angle A, and put it over 17.3. The reason I'm going to do B next is I know it has to be acute. It's not the largest angle, so at most a triangle has one obtuse angle. The other angles are acute. So I know when I use inverse sine to get angle B, and there's technically an answer in the first and second quadrant, only the first quadrant answer is going to be relevant to our problem. If I were to do angle C and have to take inverse sine, I wouldn't know for sure if the answer was going to be in the first or second quadrant. All right, so we can multiply both sides by 13 to make the 13s go away. So sine of angle B is sine 26 times 13 divided by 17.3. So 0.3294. Again, technically sine is positive in the first and second quadrants, but we know we only want the first quadrant answer here. So when we do inverse sine, we get 19.2 degrees. That's angle B. And then to get angle C, we know we have a total of 180 degrees, and just subtract what we've used. We've used 26, and we've used 19.2, so that leaves 134.8 for angle C. And we're done. All right, so let's do another one. So let's do this one. Let's just call this X, Y, Z. Oops. 6. So X, Y, and Z. So let's use 35, 19, and 20, let's say 24. So let's see, so side X would be 24, side Y would be 35, side Z would be 19. Again, notice there are no angle side pairs, so if there's not an angle side pair, we have to begin by using law of cosine. So it doesn't matter which angle we find first, but the only one that we're not sure if it lies in the first quadrant or the second quadrant is which one? Y. Y, because angle Y has to be the largest angle because it's across from the largest side. So it's possible that could be obtuse or it could be acute. So until we actually find our angles, we're not really sure. So we don't have to find it first, but law of cosines will tell us which quadrant it's in. If we get cosine of angle Y to be some positive number, cosine is positive in the first and fourth quadrant. Well, we're not going to have a fourth quadrant answer for an angle in a triangle. So if it's positive, it'll be first quadrant. If cosine of angle Y gives us a negative number, well, cosine is negative in the second and the third. Well, we're not going to have a third quadrant answer. So we would have an obtuse angle. So the sign that we get when we solve for cosine Y, that's going to dictate acute or obtuse. So if we're looking for angle Y, then that's the angle we're going to be taking cosine of. So 19 and 24, those are the sides that make angle Y. So that's what's going to go with a cosine. So we're going to have 19 squared and 24 squared, and then 35 squared goes on the other side. Angle y and side y are on opposite sides of each other. So now we just need to run these numbers, and we have to be careful. We have to make sure we use the order of operation. So on the left side, 35 squared is 1225. Now the right side is where people often mess this up. Let's just go ahead and square the numbers out. There's nothing inside parentheses to do, so exponents are next. So 19 squared is 361. 24 squared is 576. No more exponents, so multiplying is the next thing to do. So negative 2 times 19 times 24. So negative 2 times 19 times 24 minus 912. That's the coefficient of cosine y. So we can't do 361 plus 576 minus 912 because that 912 goes with the cosine y. So we want to isolate the cosine y term and have every term that doesn't have a variable in it to the other side. So we're going to subtract 361 from both sides, and we're going to subtract 576 from both sides so that those cancel. So on the left side we have 1225 minus 361 minus 576, so 288. And on the right side, we have minus 912 cosine y. So the opposite of multiplying is to divide. So divide both sides by minus 912. So those cancel. So we're left with cosine y equals 288 divided by negative 912. So negative 0.3158. Since that's negative, when we do inverse cosine, we're not going to get a first and second quadrant answer. The answer that we need is going to be just in the second quadrant because cosine is negative in the second and the third quadrant, but we can't use a third quadrant answer. So 108.4 is the answer we need. All right, now that we have an angle side pair, we can use law of sine to get the others. So we can do z next. So we can do sine of z, side z, and then sine of 108.4 degrees, which is angle y, over side y. So multiply both sides by 19. So sine of z is whatever we get here. Oops, let's clear that. So sine of 108.4 divided by 35 times 19. So that's what we get there. Z would be the smallest angle, so it can't possibly be obtuse, even though this equation has a first and a second quadrant answer. Since we're doing sine and sine is positive in the first and second quadrants, we only need the first quadrant answer. So inverse sine gives us 31 degrees. And once we have two angles, we can subtract them from 180 to get the other angle. So 180 minus 108.4 minus 31. So 40.6 is our remaining angle. So if we don't have an angle side pair at the beginning, and if we're not able to find an angle to begin with in the triangle to give us an angle side pair, then we can use law of cosine. Essentially, if we have three sides and don't know any of the angles, or if we know an angle between two sides, we're going to begin with law of cosines. We could use law of cosines 2 or 3 times in the triangle, but once is all we have to use it on these two situations, and we can finish out with law of sines once we have an angle side pair.